There's been a lot of questions about the drivetrain of this project, so what I thought I would do is I'd make a video that has two segments of it, one that has the original plan from October of 2023, and one that has the updated plan of September of this year, 2024. Hopefully I answer all of your questions, but if I don't, you can ask them in the comments or you can ask them on the Discord where I can thoroughly explain all of it. Otherwise, on to the first part of this video. So, some packages arrived. It came on an adorable little pallet. The other thing that arrived, oh my gosh, it weighs way too much, which is inside of that pallet. This is our differential. And inside this box is that. A few other things arrived. 4 wheel hubs, one of the 4 axles, a drive shaft. Drive shaft was $99 counting tax. Each differential was just over $400 counting tax. All the wheel hubs, I think they were $38 each before tax. Each of the drive shafts were $63, and I think counted tax and shipping, I think it was $317 for all of that. It is currently 4:27 a.m. I'm tired. I want to be in bed, but I have some boxes that I've been wanting to open for a while now. So we've got some hole saws. That's going to be for the metal tubing when that arrives. These are our wheel hubs. Ooh, shiny. We have a rear wheel hub for the GT86/BRZ/FRS/IS300 hub for the axle that fits the diff for those cars in particular. We have a 5-bolt pattern, and I specifically got the ABS version, and all 4 of them, this one, 2, 3, 4 of these, we need a driven hub for each tire. So I got the ABS so I can actually put a ABS sensor on there. I was looking around to see what voltage an ABS sensor outputs, and it's perfect voltage for like an Arduino to read. I'll be able to accurately, above 3 to 5 miles per hour, check the actual rotation speed of this, so we can actually compare cars driven tire speed versus, I don't know, maybe we'll do some fancier stuff later on, like a GPS integration, so we can figure out how fast the car's moving physically versus how fast it actually is, and we can start thinking about how we're getting slip in, calculate with some angle and stuff. But yeah, no, that's super exciting to see. Next box. Inside this box should be our 4 axles. For some reason they shipped 3 axles and 1 separately. Here is our axle, which is quite beefy. I'm starting to really worry about weight on this thing, but you have to remember we are removing this whole section here. Not the entire thing, but we're moving about 8 inches of it. That's to make the car narrower. I have the original leaf axles I can practice cutting and welding back, but these will be the final ones. I know these are rear axles, they're not front axles. I did check how much turn radius they have. It should be fine. Keyword, should be fine. Let me make sure I actually have the other 3 in here. They're the same part. I don't know why I was expecting a different box. It's the same for here. Yep, 3 of the GSP NCV 69 nice 110 CV axle. I purchased all these parts specifically for a 2013 Subaru BRZ, mainly just because one of the diffs is from a 2013, the other one is from a 2017. Should be the same part number. So these are just all for the 2013 model. This part I've been really worried about. So this is our drive shaft. Each side of this drive shaft has to be connected to a differential, the exact same differential. It looked like one side obviously is for the differential, one side's for the transmission. There's a joint somewhere on one side. It looks like a coupler, and I'm hoping that I can disconnect the transmission mount from it, and I'd have 2 ends that fit a differential. Hypothesizing that length of the drive shaft, which is right here, will determine the length of the car's center tire. But let me prop this up for you. So here, this end down here, we have the differential mount right there. So we have our 4-bolt pattern. And then up here, we have the spline that goes into the transmission. Right after this U-joint, we have the exact same bolt pattern as that side, which means I have a drive shaft that fits 2 rear transmissions. That's perfect. So whatever this length is here, and it should be balanced too, so I don't have to cut this up, hopefully. Foreshadowing if I have to for some reason. Don't know yet. So on one end will be, we'll go this transmission, which is wrapped really generously. I'm not complaining about it. But anyway, I'm super excited to see this. It does look a little bit shorter than I thought. Right now, it looks like here's my axle here, we are approximately from the flange to the center of the tire is about 11 inches. Let's see, how long is this? This is approximately 34 inches. We have 11 twice. So 22 plus 34, 56. Did I do that math right? That's 56 inches between tire centers. Oh, that's gonna be nice. This actually might be the same length as the Power Wheels. Yeah, so our center to the center will be the same length of the Power Wheels. Now I think about it, I think the battery box is 22 inches long. I'll have to confirm that, can't remember, it's been months since I looked at that measurement. Here's 22. Oh yeah. And the reason what I'm checking right now is this drive shaft is going to be dead center, both left, right, and front, back of the vehicle. So the battery pack has to sit roughly like the 250-pound modules will have to sit side and side. And so roughly for a visual, this is 22 inches. It will sit, I mean, it's significantly shorter than the drive shaft, obviously. We'll have plenty of room, it looks like, for left and right battery. I'm a little bit worrying about the main 300-pound battery section, how that's really gonna fit, but we'll worry about that later. I have an idea, don't worry, it's an idea in progress. This is telling me that I have some hope. So we had drive shaft, we have axles, we have wheel hubs, we have our first differential. Now look at the mini adorable tiny little crate. Isn't that adorable? How to open this? This looks a little bit intimidating. Oh, that was way easier than I thought. Wow, this is not saran wrapped like the other one. It's just straight up right there. I don't know if I told you yet, but both of these, this one and this one, are LSDs. Not like the drug, like the limited slip differential kind. Yeah, those splines look actually really good. It smells awful. I haven't had to use diff fluid before, so it could just smell awful like normal. Let's take that saran wrap off. This one's upside down. Or maybe that one's upside down. I guess I will flip that upside down after I finish cutting this out. Honestly, seeing how much oil is trapped in here, thank you whoever strand wrapped this. This is making my life a lot easier. Things covered in oil. These things are not light. Okay, relatively not terrible. I remember it being a lot heavier. Get that out of there. Oh. Look at that. I am now a proud owner of a mini pallet. No idea what I'm doing with this, but I'll do something. I have some sad news. As you see, what's on the ground is not exactly the same place it was a second ago. GoPro overheated and I lost about 20 minutes of footage. Now that may not sound like a lot, but in that time, I was able to take the drive shaft out and remove the 4 bolts from this transmission connector of the drive shaft. That basically just pops right off after finessing. I was so happy that it seemed like it was going to work, and it sounds like I'm foreshadowing something here. It's because I am. These flanges look identical on both sides. They look pretty darn similar. You know, it's 4 holes and you got a little flange there. Well, turns out they're not the same size flange. One has a flange size here of about 45 millimeters in diameter. And the other side, let me check one more time, has an outer diameter of 49. It's ever so close. Turns out the bolt holes are also square on both sides. That's great, right? They're not the same spacing between each other. This one has an outer to outer of just about 67 millimeters, and this one has about 71. The bolt hole on this one is, I imagine it's M10. The hole is 11 millimeters. And this size is 10 millimeter hole, almost exactly. For sure, until I go over here and see if this pile is the same as this pile. They are not the same. They're the same diameter. That thread pitch is very different. What am I going to do about that? Oh, that's right. Before the camera turned off, I was explaining. The idea is one side obviously connects right to the diff like normal, because that's what the flange is for, you know? And this will fit right into there. Yeah, that fits nice. If we have a diff to a diff, we need some way to power, you know, we need some way to get power into the drive shaft to split out. And that's because I'm going to have a sandwich gear or 2. I don't know yet. I have to figure out what I can get and what their strength ratings are. Maybe I'll go order some 1/2-inch plate of aluminum. I have some quarter stock and 8 stock, but that's not thick enough. Put on the CNC machine, machine out a flange that would fit both that and this for the drive shaft and the diff, just to make sure, you know, actually, in fact, save on material. I'll 3D print it, make it out of plastic, make sure that fits, and then I'll have to figure out the gear that I want. Hopefully what gear we'll finally end up using, because we need to sandwich this gear somehow. So between this flange here and that flange there will be a gear sandwiched. The motor sits right over on top of the rear differential, and for just the sake of mock-up, let's pretend this is the rear right now because that's not the connected one. Axles go out to the wheel hub, to the tires. Same thing if we're over there. So I'm going to bolt that up and we'll get a general mock-up. Drive shaft, let's pretend it's spinning this way right now. From your perspective, this is counterclockwise. And let's say for just spinning it counterclockwise, makes it drive forwards from your perspective, that way. If I look this way, from this diff's perspective, it's clockwise. It's moving the reverse. So by spinning this one drive shaft in the same direction, and they're both upwards, that means that they should both be driving that way. And since these are both geared the same way, they should both be moving at the same rate too. So I'm just gonna sanity check myself, take a peek in here. Oh, thank goodness it is. Okay, it's moving this way as well. So let me get an axle out, see how that fits. So this is the side that goes into the diff. This is the side that goes onto the wheel hub. That's definitely rotating that. Yeah, that's a little bit. Obviously, it's not clipped all the way in yet. This seal has to meet up against the seal over here. So we have another, I don't know, that's probably about an inch or so. Let's get another one on there. Put that. Yeah, it's way too wide. Kidding me? Look how it's practically almost as wide as it is long at this moment. 66 inches or 5'6". I'm looking center to center here. 4'8". We are a whole 10 inches wider than we are center to center. That's not good. Obviously, we have 2 inches to cut off here, 5'6", so we'll call that 5'4". Guess what? We need to cut in half. I already knew I was gonna have to cut them. Little glimmer of hope that maybe I didn't have to. I'm gonna have to. What I wanna do first is I wanna see this hub fit on this axle. Hopefully this fits. I mean, it should. It's for this. It's really wide. Now that I have it all laid out, this is what we have. So, like I said before, the electric motor will be right above this diff. And then on top of that will be the inverter for the motor. And then for the actual charger, it'll be too high if the charger sits up about right here. So I'll take off the charger, which is literally about this amount of thickness. I'll take that off and I'll probably move that actually to the rear section. I don't know quite yet. I can really place it anywhere I want that I have room. It doesn't really matter because it's a charging system. It's not like I'm pulling power straight through it during, you know, running. The charger is a 6.6 kilowatt charger, and there's a few ways of how I'm going to get that working. We are about, 64 inches exactly, minus 2. That's 62 inches. Yep, that's 4'8". Remember, that actually might change that way because of the coupler that I need to add there. So that's 48 and 46. Okay. You're probably thinking, oh, that's going to make your this vehicle look square. I don't like square vehicles. Trust me, I don't either. But the fact that right now this actually looks decently square the way it is, and I'm going to be removing just under 1.5 feet from its width, tells me that it's going to definitely true up into a rectangle. And remember, they still have the nose and the tail to go. This is just the axle part. Aha. We are very symmetrical. So it's a little bit brighter in here than last time. So let's bring everything back out and I'll show you the brand new part that I'm very excited for. It's not actually brand new, but it's new to me. This guy right here, and you probably already know what this is. It's a differential. And you're probably wondering, you already have two that look exactly like this. And to that, I would say, yeah, you're pretty close to right. Yeah. But they each have different purposes. They are all limited slip differentials. Like I said, 3 LSDs. These, like I stated before, are the Y38s. They're both from a Subaru BRZ. All of this is under 100,000 miles. Not in some. I think that one's 81,000. I think this one was like 40. I think this one might have been 93,000. But they're all under 100,000 miles. And that there is a G35. But the reason why we have a third one, the key difference, is what's on the side of these. Notice there's nothing here on either one of these. But this guy, it has these little flanges that come out, which is the crucial part of what makes this actually going to work. From here, what come out of them are are these axles. These splines here go into these holes here on each side. And we have 4 axles. We have 2 holes on each of these. So that's where all the 4 axles go. You're probably wondering, chance you have 3 differentials. That means I have 2 axles on each side. So you should have 6 axles. And you're making a car with 4 axles. Well, this one's not going to have 2 axles connected to each of these sides. And that's because these aren't going to be driving axles. They're going to be driving the input shafts of the differentials. And that's because, let's just say, this is going to be our front diff, and this obviously is a rear diff. They're both rear diffs, so we're going to be using it as a rear diff. That there, that's going to be way in the front, connected by this drive shaft. Right there. You know, pretend that's connected for right now. So, diff. These two can be connected to each other through a adapter plate. These can be connected through an adapter plate, and these obviously will just connect because that's how a diff and a drive shaft mate. Why do I have this thing? It's because I had to remove this from this end, because this went to the old transmission of the Subaru BRZ, which we are no longer using, so we can forget about this right now. So these axles go into the differentials, they go out to these wheel hubs and everything. Wow, they've been sitting for so long. They have spider webs on them. On the back of these hubs, we have these 4 big bolts right there. That's perfect, so I can make the wheel hub and everything these hubs will attach to. That way, so we can have all the heim joints so we can turn the wheel and whatnot. These are rear axles. That way, so we can have driven, because the BRZ is rear-wheel drive. That means, yes, we'll be using rear axles for steering, which means, yeah, we get about that much steering. It means we're probably not getting as much as normal, but we're not drifting with this thing. It's all-wheel drive, so, you know, that's not much of a dilemma. Now, if I was going for the drag strip, this would have been rear-wheel drive only. We would have forgot about all of that. To be honest, if I really wanted to do drag strip with this kind of stuff, I would have kept the original Nissan Leaf subframe intact and welded the diff inside of the 1-gear transmission on the Leaf. That way, so we could just have rear-wheel drive only. The Leaf is front-wheel drive, but we would have put that subframe in the back. And that would have left plenty of room for the batteries in the front. Would have left a lot more room. Instead of having batteries in the front, we're going to be having this stuff. But I wanted all-wheel drive, which is going to make this thing approximately 200 pounds heavier. Don't really care. We're already here, and all-wheel drive is a lot cooler. My old design, I didn't have a diff here. I just had this connected to here. Why is that different? And that's because how turning radiuses work. So when you turn, you pivot off of the rear tire that is on the side that you're turning towards. AKA, if you're turning right, you're mainly pivoting off of your back right tire. Left, back, left tire. The reason why I say it in asterisks is because while you're turning, that tire is also spinning, which means you're moving out of the place that you were turning from, which means the point of turning is shifting, which means it's not that tire perfectly. We'll get into this more in a bit, but it basically means that the tire is furthest away from the tire that is pivoting is turning the most. Okay, if you're turning left while driving forward, your front right tire is going to turn the most. And that is because it has the furthest distance from your back left tire. If you're turning right, your front left tire is the furthest from your back right tire. Therefore, your front left is turning the most. Let's compare the front and the back. Since both of your front tires are further away from either of the rear tires, your front tires are turning more than your rear tires, which means in a turn with all-wheel drive, you need something to manage the difference in rotation of the front to the rear. Now, say you were in 4-wheel drive and it doesn't have a differential in the middle. We're talking about a locked differential. If it's a locked differential, it's not really a differential, let's be honest. Say you put in 4-wheel drive, where it's not going through a differential in your transfer case or whatever you're using. That means that when you turn, there's going to be an excess amount of force on your front axles, your front hubs, your front tires. It all wants to slip, and your front differential also. Everything wants to slip. It doesn't like that. That's why you can break axles and stuff when you are in 4-wheel drive when you're not supposed to be. That's why 4-wheel drive is not the same thing as all-wheel drive. All-wheel drive is having a differential between your front and rear. And that's what allows power to be evenly distributed. And evenly is even with an asterisk because of the difference in rotation speed and stuff. It's more about torque loading and everything. So basically, if I went my 4-wheel drive route of having no differential here, if I wanted to turn, it would put a lot of stress on this stuff, especially since this differential, we're going to be running backwards because, well, turned around and it's moving that way. That's backwards for that differential. So we're just reducing the amount of stress that we have on this system. Yes, it adds a lot more weight. Yes, it adds a good 1.5 feet of extra distance. That's okay, because there are workarounds for that. So let's just pretend that is suited there, and let's pretend that's clicked in right now. pretend this axle is straight as if this is connected to here. Let's assume this axle right here is perfectly perpendicular to the drive shaft when it's connected to the actual flange here. That would put our center about, let's see, this is around a foot, say another 34 inches. These are mirrored, so that's another, so 2 foot, 34 inches. 34 plus 13, 47. Count, let's say half-inch plates, so call that 48. So that's 4 foot there. So that's 6 foot. So we have 6 foot in between centers of our axles. For this thing being around 7 foot, which is what I'm aiming for, puts us under our 7 foot, which is good. But that also means that our wheels are very close to the front and very close to the rear, which I do not like. But there is 2 other things I need to fix. And that has to do with how far this thing sticks out from way over there. And that's not even counting the tire width yet. So let's say that's halfway, all the way out to the flange plate here. Subtract 1 inch, considering it's not pushed in all the way. We are at, say, 31 when it is pushed in. 31 times 2, 62. What is 62? About 5 foot 2. That means without tires. Let's assume the tire edge is like right here, which we're at 5 foot wide, which is bad. I mean, obviously these axles are designed for when they're on a car, you know, so everything makes sense to be that wide. There is some things we can do to minimize our width, considering I'm more aiming for about 4 foot now, maybe 4.5. I wouldn't be upset if this thing ended up being 8 foot long, which it probably will. So maybe 8 foot by 4.5. I don't think the 3.5 by 6 foot is reasonable. I couldn't even get the 4-wheeler to do that. So putting, you know, much more expensive, bigger, more powerful components in, I don't think would be smaller. So I guess we're gonna have to go a little bit bigger. To get this down from 5 foot down to realistically closer to 3.5, because remember, tires are going to add on to that. First idea is to cut this axle here, you know, cut in like, you know, like here-ish, here-ish, bring them together, re-weld them back together. I could either try that myself and fail horribly when they inevitably shear off because I don't know how to weld properly. So I could go and hire someone to weld that up for me. That might be what I end up doing. Or I could try it, mess up, and then pay someone to do it, which I probably will end up doing because I might as well give it a shot myself. But the other option, I know I'm going to get yelled at for this, but the other idea is to remove the idea that that is perpendicular to here and do that. The issue is that the CVs do not like to do that. They don't like that. But hey, that just bought me a full, I don't know, half a foot. That might be fine for the rear. Ignore this as the front, because all the rear really does is, you know, up and down. The front has to turn. If this is almost all the way locked, you know, that way it can go, I obviously can't turn right here or closer to you. I could turn really good this way. Yeah, that kind of defeats the purpose if you can only turn one way with one side of the car. So I can't do that with the front. The front will have to be pretty darn in line. So our main option of what we have to do is cut and shrink the axles. The good thing is though, we have around, let's just say we leave 1 inch from each of the boots. The boot is around 13 inches, so that leaves us around 11. That means almost a foot of reduction on each side, which is fantastic. Downside though is the smaller you make this, the lower amount of travel you can, oh geez, that's heavy. The lower amount of travel you can go up and down. Now, with the way things are going, I'm only expecting amount of travel of around 2 inches. That is not a lot at all. But when you're shrinking this thing about a foot, I probably won't remove 11 inches from this. I'll probably remove like 8. I don't need to go that overkill. If I really wanted to go overkill, we'd have, you know, the tires mounted straight to the differential, which obviously removes turning, but hey, that's narrow, right? But yeah, that would reduce our, from flange to center of diff from around 31 inches down to about 20 if we remove those 11 inches, which puts us in our room of working. That's why I said we're gonna have to drop the idea of around 3.5. 4-wheeler is 4 foot, and that's still not gonna work. And that diff is like half the width of this one. But we'll see what we can do. Now on to the next part, the funky part. Yes, we have our outputs, our differentials to our hubs, to our tires. We have that. Are we forgetting something? Yes, we are forgetting something massive. How do we go from motor to the wheels? Where does motor go to the diff? How does the motor get to drive shaft? How does the motor get to the rear one? How does the motor get through this center differential, even though it's a rear technically one that we're putting in the center? It's called a center diff. How does power get to the center diff? Well, I have 3 options. One would be we take this diff, we turn it upright. Oh, Jesus, this is heavy. It's full of fluid. Turn it upright, and then we place the motor vertically on it. The motor goes straight into this, spins it. Oh, that is leaking fluid out of the airport. The motor would have to be facing straight down. the power of this. The second idea is we place the motor on top of it facing that way, and we do a chain drive here. This is where chain drive starts to come in. And we chain drive the front hub. So we put a sprocket on here, and we put a sprocket on the motor, and we chain drive this. Now that sounds doable. You know, we mount the motor. We have to get rid of these bushings out of here. That way so we can hard mount this to the motor. That way so there's no like flex between the chain and everything. That would be bad. We could do that, but you know, we'd have to have some pretty intense chain tensioners in there, which I don't feel like doing. The other issue is that the electric motor spins at a maximum of 10.3 thousand RPM, which is a lot. And the original like gearing down ratio of the Nissan Leaf transmission was 8.3. So you're probably starting to think, why is, gearing down ratio, do we have to gear it down to here? Well, no, these differentials already have gearing ratios. The front and the rear, I can't remember if they're 4.1 or 4.3. I'll check later. This guy right here, it was 3 something. I can't remember. It was like 3.5. Anyway, I don't care. The gearing down ratio ended up being something like 12 something, 12 or 13 something to 1, which is a decent bit more than 8. You're probably thinking, well, 12 isn't, it's only 4 more than 8, right? Well, when you're thinking about it in ratios, it's 50% more slower than 8. Is it 50%? Is that how that works? It's slower. When you do the math, the max speed of the Nissan Leaf is around 90 miles per hour. The max speed with this is around 60 miles per hour. If we just have the motor straight connected to this differential, just like 1-to-1, the output of the motor to the input of this differential, which obviously when we're doing, you know, like 400 foot-pounds of torque, I don't want my max speed to be 60 miles per hour. Yes, in go-kart world, which this is beyond go-kart now. This isn't go-kart. This is in between land of go-kart and car. 60 miles per hour is not enough for what we're doing. So say I did the gear up. So I put a bigger sprocket and a smaller sprocket on here. When you do the math, this would be spinning around 17,000 RPM. I don't think you want to spin a differential at 17,000 RPM, especially since the input of these, let's say your transmission has a 1-to-1 ratio, you know, where your engine is spinning the same speed as your differential input is, and say you're full revving your engine, that's 8,000 RPM. So these things are, you know, and I think the BRZ has a rating of like 8.5 for redline. I can't remember. 8,500. So the max I would be comfortable putting in this is 8.5, which is, if you've noticed, is less than half of 17,000 RPM. Actually, it's exactly half. So now you're seeing the dilemma that I was having. This has a gear down ratio. How do we remove that? Can we remove the gear down ratio of the front and rear ones? Kind of. So you can change the main gear inside of these differentials, but that really only changes it by around 0.1, 0.2, maybe 0.3 if you're lucky, and you have to find those parts. And then you have to like check backlash in the differentials, and I really don't want to deal with that. So front and rear differentials are staying stock. I mean, they're LSDs, but still, they're staying stock. This guy will not be most likely. I'm thinking about removing the main gear entirely out of this. And you're probably thinking, well, how do we power this if the pinion that's on the input shaft and there's no main gear in there, it's not going to spin anything? Yes, you are correct. And that's because the main gear is going to be replaced with a sprocket. Yes, we're getting sketchy here. Just like how originally I was going to put a sprocket in between here and the rear diff, I'm going to put a sprocket instead of the main gear. And that way we can put a 1-to-1 ratio on this differential, because the gear down ratio comes from how big the main gear is to how big the pinion gear on the input shaft is. Input shaft one has a little gear, and then the main gear that's around the differential is big, and so there is a gear down ratio. If we have our main gear directly driven, then we remove that gear ratio. That way, so the motor, let's say there's a sprocket size is the same sprocket that we put on in place of the main gear. Gear down ratio of the motor, electric motor, out of these differentials will be what only these two outer differentials are, because it's 1 times the 4.3 of the front and rear, which is good, but that is too fast. I'm aiming for around 110 miles per hour with this thing. That is the goal, because the Nissan Leaf was around there as well. I'm trying to aim for the original gearing of the Nissan Leaf, so around 8.3. A little bit higher I'm fine with. I honestly kind of want to stay a little bit lower. I don't really know. I want to have that good, you know, low-end torque balance, but also have some high-end, because there's only one gear here. Yes, I thought about putting a transfer case in here. Downside, though, is they're a lot bigger, a lot heavier, and a lot more finicky. So, especially since the input and the output of the front are like on the same side, but like offset, so this thing would be like way over here-ish. you know, instead of like in line. So I did almost buy an F-150 transfer case. Really good deal on one, where they had the electronic switching between high, low, and all that stuff. The only thing is, it comes down to the issue of that's four-wheel drive versus rear-wheel drive, which means if you want to do anything track related, you have to leave it in rear-wheel drive, because any turning, you're going to put the excess stress on the front, and you're already going fast corners. You're already putting a lot of extra stress on the front, considering it's already running in reverse. That's kind of out of the question. I had to stick to a differential. I mean, yes, there are transfer cases that have differentials in them. I think there's some Escalades or some Tahoes that do, but those transfer cases are much bigger and much, much more expensive, and I don't want to look at that. Smaller differentials like the Suzuki Samurai, yeah, they're very small, they're manual. Yeah, because of, how rare they are nowadays, those transfer cases are very much even more expensive, so we're not even going to look at that. So we're just going to deal with this. Yeah, but the Tahoe and the Escalade one, transfer cases, those diffs that are inside of there are open, if I'm right, so that's like defeats the purpose of, all-wheel drive, limited slip, blah, 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 because if the front slip, then you're losing power in your rear, which, I don't know, I just don't feel like that's right. So limited slip in the middle too. This leaves us with some conundrums now. We want to remove the main gear and chain drive it. Now, since we can't fit the motor inside of this casing, the motor's obviously going to have to be outside of it, which means the chain has to go somehow outside of it to inside of it. And I have a few possible options. One, the drastic approach is cut off all of this, all of the top part, just remove it, cut it right off, have a giant hole in the top of it, have the chain go straight down into it and spin some fun stuff. Downside of that, now you have a giant hole in your differential. I know, who would have thought? This differential is not the same kind as this rear and front. This is called a V LSD, and those are clutch type LSDs. Rely on clutch plates inside of the differential. A V LSD is a viscous LSD. This relies on fluid level and fluid pressure and other fun stuff that I haven't fully read up on, because I understand those, but needed something like this, and I didn't want to get a viscous one, but here we are. I am worried about fluid not being there when there should be fluid. Especially, obviously lubricating everything else. One of the big points of the fluid was to lubricate the main gear and the pinion gear, which we're removing. But the other parts, I like to lubricate the bearings that are in each side here. Is another reason why we're keeping the casing, is because it has already these mounts locations and everything. It's already strong there. Yes, we would be cutting off the top and we would be losing a lot of strength. But I would have to cap off the top, the seal around the chain, or we make the top of this extended to go around the faceplate of the motor. And since I don't know what mystery metal this is, if this is cast iron, or I don't know if this is weldable, is what I'm saying. Boltable? Yeah, you can bolt stuff to it. I'll have to test and experiment on that. All I'm saying is that there's fluid in there. We have to contain it somehow. The alternative idea, we just remove the input shaft to this, have the bottom half sticking upwards, and then chain drive it from there. And then since we already have a good sealing surface, we can make a box, an enclosure that sits right on top. Yes, we'd have to block off the passageway of where the shaft is and everything, but I think that might be a lot easier than cutting literally half the differential off. Well, now you have the issue of ground clearance, because this being downwards, you have a full 10 inches sticking downwards, and we're already going to have probably half a foot below this. That's going to be in the ground, so that's an issue. Working through problems with that, the most likely idea that we're going to have is we're just going to straight up cut this off, or we put the motor facing that way, like the first idea, just train drive it and just say, yep, 60 miles per hour is max that we're going to go, and we're going to spin this at 17,000 RPM, which is going to induce a lot of losses and probably blow up behind our back, which is going to be my back most likely, which means I'm probably going to lose my spine, which I don't want to do. So there's some engineering work to be done with that. Another cool reason why I chose this one is on these axles, there is this little metal plate here. It is to cover the ABS sensor, because there is a magnetic ring underneath here, and the little sensor goes in there. It tells you how fast the wheel is spinning. Great, we have the capability of ABS sensing on all four corners. Will we have ABS? I don't know, probably not. But we'll be able to know the wheel speeds and everything, so I can code in some traction control or whatever, depending on steering angle, how much rotation around the pivot of the rear tire, quotation mark. We'll figure out some traction control. But the other cool thing is we can calculate, if we have the front two tires known speeds, we can back calculate what this speed will be. How do we check that though? Well, conveniently we have this third diff in the middle, which has this little ring right here that has these little notches in it. And I have these cool fun little wires, which are proper ABS sensors. We can tell how fast our outputs are. So we can compare against this output and our manually calculated input. So if there's any weirdnesses between there, we'll be able to know. Oh, yikes, if those are different, something's blown up. Probably have, if there's a threshold value there, if it's too much different, we'll have like an auto shutdown or something. Same for the rear. On both sides, there's a sensor. On each four corners, we'll have a sensor. I'll also put some a GPS speedometer into this. I won't be like one of those display ones that just sit in the corner of your car that only tell your speed. I'll get like an Arduino based one, that way so we can do some back calculating and make sure that we're not doing anything major slipping. Those things aren't totally accurate, the GPS ones, but they'll give us a general idea of what's happening. Considering all four wheels are driven, we don't have a wheel that we can base our speed off of. Like in a front wheel drive car, you can use the rear tires to base your speed, and in a rear wheel drive, you can use your front wires to base your speed because they're not driven. They're most likely not going to slip. So you have a better idea. With all-wheel drive and four-wheel drive, you don't have a tire that is solid to the ground that's non-driven. So you don't really know definitively what your speed is. You only know what speed which tire is going. It's not necessarily what the ground is. Blah, blah, blah. Other reason why I'm really excited that this is in, that it's been so long of the last time I had this out here. I don't know if I've already shown you that footage or not, so far ahead of videoing, but I haven't been able to decide any of the frame dimensions because this hasn't been here. Haven't just figured out what was going to be here, but now that we do have this here, I know the width between all of this. I know this. I know how far the front is from the rear. That's because this is in, there is a set distance that we have to work with. This is going to be plated up to there. This is going to have some kind of weird mounting system from here to there and from here to there. Unfortunately, both of those plates will be different because the bolt pattern between the front side of this drive shaft and the rear side is different. I don't know why they did that. It's only like 2 millimeters different, but they did. Anyway, custom plate, since this is a 6-bolt pattern, this is a 4-bolt pattern, there is no threading issues. So, aka there's no spots where this thread wants to be and that thread also wants to be. Also, the diameter of this one is a lot bigger. So also another issue passed. The only bolt pattern issue I have is on the hubs to our tires, because our hubs are 5x100 because they are used on the Subaru BRZ, Scion FRS, the Toyota GT86, have a bolt pattern of 5x100. And the tires that I have and the brake rotors that I have are 5x114. aka this is a 5x4 and the tires I have are 5x4.5. So that just means that there's 5 lugs here, but they're closer together than the bolt pattern of the tires and rotors that I have. Yeah, it means that either I have to get an adapter plate goes on all of these, which adds extra width, which we don't want, or I can find other hubs, or I can replace this outer plate and everything. Not the cheapest, but also if I wanted to get spacers, convert 5x100 to 5x114, it would be around $90 for all of it together, which honestly is not that bad, and I'm probably going to do that. But it does mean that my rotors are going to have to be on the outside of the spacers. That's just not right, but it might just be what we have to do. And I'm sticking with those rotors because I have them, they're cheap, they're easily replaceable, and I already have brake calipers for them. In conclusion, rear diff as a front diff, rear diff as a rear diff, rear diff as a center diff. Drive shaft that is supposed to go from a transmission to a rear diff is going from a rear center diff to a front diff, and these are all going to be bolted up to each other. And then we have regular size axles that will be cut in half, shrank, and yeah, and then plates to adapt them up to a larger bolt pattern size. Even though I would really like a bolt pattern of 4x100, but that's not going to happen. If I really wanted smaller tires, I could go the trailer tires, but as you can probably imagine, that's probably not the right method to go. But yeah, but at least we have progress, and we have a closer game plan to work with. I think the fact that we can have the drivetrain longer than it will actually be right now sideways in the garage is a good point about how small this is going to end up being, and I'm very, 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 very excited. I'm 5'6", so I'm not even, very tall, and if I laid down on the ground right now, from one diff to the other, my height is almost the same as all the drivetrain laid out. That means that the drivetrain is very short, and I can right about see all the way down. It's gonna be good. Gonna be good. There is so much more work to do. So I suppose it's time to get 3D scanning all of this. That way so we can start making our model. The brake rotors are right over there. Okay, steering wheel, I'm not using this. I have it because it's the same pattern as electric power steering. This has an emergency thing about it. You apply 12 volts, it sees that the computer's not there, it just turns on and it starts working. Car knows that something's very broken and very wrong. At least you should have power steering. Same thing for power brakes. I don't have that right here. Here's all of our rotors. Very rusty. And that is because they've been sitting for almost a year and a half. Oh yeah, all the brake calipers are in here too. And here's the ABS module. Yeah, and you know what's really cool about this? It's a Bosch unit. I thought this was a Bosch unit. I think when I googled it, it came out to be Bosch, but it says Nissan Hitachi on it, so I could be wrong. But the cool thing about this has 4 outputs, and it's labeled front left, rear left, front right. So if I somehow figure out how to get this working right, I can potentially have ABS. And when I say potentially figure out how to make this working right, I mean I'm going to scour the internet to see if I can find anything about this. And then when I find that I can't find anything about this, the electronics are coming off, and I'm going to figure out how the little solenoid valves in here work. And we're going to end up rebuilding the electronics in this for ABS. Because that will be a cool, fun project when the brakes are already in and the car's already running. And once it's completed, we can, you know, add that little extra touch of spice to it. But yeah, 4 brake calipers, 4 massive rotors, power steering, and a potentially a solution for future ABS. Honestly, I really don't even think we need the power steering, but you know, we have it. Oh yeah, for the people who think that 114 is really darn close to 100, yeah, they don't fit. Yeah, that don't fit. This is just the first video of this project. I release a video every single Monday, and so far we spent around $5,500, with the stuff in this video alone costing around $1,500. If you want to support, there's a Patreon, a Ko-fi, and a Discord if you want to find out more about this project. If you want to watch more about what you're seeing here, there's a subscribe button to get notified for when a new video comes out. Additionally, here's a playlist and a video YouTube thinks you'll like.